Today, my group will present about an advanced reactor technology for production of clarified apple juice and apple juice aroma concentrate. The reactor that we choose is Enzyme Membrane Reactor. Before we start the presentation, I would like to introduce my group members. My group members consist of 4 members. The first one is me, myself, Nur Faika binti Jamaluddin. The second one is Wan Nusyairah binti Wan Tadarus Samsuri. The third one is Nur Atirah binti Mat Naim. The last one is Nurul Ain Syahida binti Azmi. In this video, we're going to describe about the production of clarified apple juice and aroma concentration, followed by enzyme membrane reactor. We're going to describe about the reactor itself. The third one, we will present the schematic diagram of the reactor, which follow the function of each component in the reactor. And the last one, we're going to discuss about advantages and disadvantages of the reactor.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ain Syahida binti Azmi. I will explain about the process description of process producing apple juice. So, this process of production consists of 2 types of process, which are conventional process and integrated membrane process. Conventional process is the basic process in the production of apple juice, which is starting with the fruit handling and juice extraction. Then it continues with the aroma recovery, then clarification, and lastly the concentration process. This type of process different with the integrated membrane process because it doesn't have to do the pre-concentration process, and the aroma recovery process is run before the clarification process. So, here are the fully conventional process of production of apple juice. It started with the washing process. The fresh fruit will be washed by the water. Then, it will have steaming, destoning, and peeling process. After that process, it will have milling, crushing, and grinding. After that process, the fruit will have the enzymatic treatment process, which consists of maceration and liquefaction process. After that, it will continue with the juice extraction, which is pressing process. In this process, it will have 2 outcomes, which is aroma extraction and cloudy juice. The aroma extraction will be clarification by the centrifugation. Then, it will have a concentration process by the evaporation. Then lastly, it will become a juice concentrate. For the cloudy juice, it will have a clarification process by the centrifugation. Then, it will continue with the pasteurization. Then, it will become a single strength juice. Here are the diagram of integrated membrane process for the production of apple juice. It started with the fruit handling and juice extraction. Then, the second process is clarification. Then, it continues with the pre-concentration process. Then, the aroma recovery process, and lastly, the concentration process. In order to avoid some of the problems of conventional apple juice processing methods, the integrated membrane process was introduced. The new process involving the new operation, which are the clarification of raw apple juice using an EMR, which the EMR stands for the Enzyme Membrane Reactor. The next is the apple juice pre-concentration by the RO, which RO stands for reverse osmosis. The next operation is the aroma compounds recovery and concentration by the PV, which PV stands for evaporative. And the last one is the final concentration up to 70 degree Brix using conventional evaporation. Next, I will explain the integrated membrane process for the production of apple juice concentrate and apple juice aroma step by step. Firstly, it started with the fruit handling and juice extraction. In this process, harvesting, transporting, and washing fresh fruits are the first steps of the process. After washing the apples, they are milled to a pulp and then pressed. Catalytic enzymes are often applied to the pulp during the pressing process. After pressing, the raw apple juice will be turbid, viscous, and dark in color. It also includes a large number of colloidal compounds that are kept in suspension by polysaccharide like pectin, starch, or gums. Next, it will continue with the clarification process. The clarification process involves the removal of juice components, mainly pectin, which can cause the cloudiness. Apple juice clarification begins with the pectinization, which is achieved by catalytic enzymes. Enzymes hydrolyze pectin can cause the pectin-protein complex to flocculate, giving larger particles that settle, lowering also the viscosity of the system, so that the juice is much easier to filter. This process is usually carried out at 50 degrees Celsius for 2 hours or at 20 degrees Celsius for 8 until 12 hours. A membrane reactor combines juice clarification with enzyme recirculation. The next is the pre-concentration process. In the conventional methods such as evaporation, to concentrate fruit juice require high temperature and high energy consumption. RO is an alternate membrane process that can be used to pre-concentrate fruit juice at ambient temperature. Thus, thermal damage is minimized and lower capital and operating costs may be expected. However, it is not possible to concentrate apple juice by RO over 30 until 35 degrees due to the high osmotic pressure of concentrated apple juice. Therefore, a final evaporation step is needed to reach a concentration of 72 degree Celsius. Next, it will continue with the aroma recovery process. The aroma recovery process consists of aroma compounds that are very sensitive to the heat treatment. During conventional apple juice concentration, both physical and chemical losses of aroma compounds occur to a great extent as a result of evaporation and chemical alteration. By introducing PV to the integrated process, the aroma compounds could be removed from the apple juice prior to evaporation and feed back later to the concentrated juice, resulting in an improved organoleptic quality. The aim of the project was to characterize the juice by the identification of aroma compounds and to develop a model solution of apple juice aromas on the basis of the identification. The last process is the concentration process. Evaporation is the conventional method for the concentrating clarified apple juice. It is performed in multiple effects evaporator at temperatures between 45 degrees Celsius and 90 degrees Celsius. Simultaneously with the water evaporation, low molecular weight volatile flavor compounds are entrained, and therefore it is a common practice to remove the aroma compounds before concentration. Generally, the raw apple juice is heated in the second stage of the evaporator up to 80 degrees Celsius, and a vapor containing the volatile aroma compounds is obtained. It is then concentrated to an aroma-enriched solution by distillation.
Enzyme Membrane Reactor. In this part, I'm going to explain the definition of membrane reactor, followed by definition of enzyme membrane reactor, and then the application in this production. Membrane reactor. Membrane reactor are physically defined with combined chemical conversion with membrane separation to add reactant or remove reaction product. One example of membrane reactor that combines the operation of two units in one stage is membrane filtration and chemical reaction. When combined with the reactant-selectant extraction, conversion can be increased beyond the equilibrium that cause it very suitable for endothermic reaction was limited due to its valence. The membrane can be used for the different purposes, such as separation, which can be selective extraction of the product or retention of the catalyst. It also can be distribution of or dosing of the reactant, or it can be a catalyst support. This type often combined with distribution of reactant. Enzymatic membrane reactor or EMR consists of coupling of membrane separation process with an enzymatic reaction. Since enzymes are macromolecules with wide range of size compared to reactants, sex exclusion membrane filtration using ultra or nanofiltration artificial membrane may be used to isolate them. The biocatalyst is separate from the reaction product using a selective membrane. The main goal of EMR is to ensure that the enzyme is fully detected in order to retain maximum operation within the reacting volume. In the conventional process for production of apple juice concentrate and apple juice aroma, the enzyme was used to liquefy the remaining pulp, cellulose or etc. to soluble sugar. Because of this high efficiency process, which is 90 to 95%, only small amount of solid waste are generated. The enzyme on the other hand is extracted during filtration and is only used once. But the apple quality is an inherent variable that can cause problems. When using apple from the storage silos, the different aromatic composition of the apples can have major effect on the juice quality. Process performance may be improved to an acceptable level by changing enzyme cocktail, but this may require to purchase expensive enzyme. So, in the integrated membrane process, the EMR is applied for clarification and maceration of the juice. The enzyme is used in multiple cycles, and it also possible to immobilize enzyme on the membrane. The main enzyme complex that used in the production was epidase, which affect the viscosity reduction as the result of the pectin hydrolysis reaction.
Hi, Assalamualaikum. My name is Wana Shahira Wan Badaru Shamsuri. I will explain to you about the function of the component in schematic diagram of the reactor. First is feed time. The function of the feed time is to cooling the juice. Second is to spiral one membrane to ultrafiltration the juice that will filtrate smaller than the molecular weight, cut off, then pass across the membrane surface into the permeate spacer. Third is screw pump to move the juice along the screw. And fourth is pre-filter to remove unwanted large matters from the juice. I will explain to you about the spiral wound membrane first. The diameter of the spiral wound membrane is 0.5 m² per inch and have a few of elements such as membranes, feed spacers, permeate spacers, and permeate tube. First, for half-folded membrane, it will facing inward. Second, for feed spacer, put in between the membrane, it is called membrane sandwich. Is to provide space for water flow between membrane surface and uniform flow. Third, the permeate spacer glue with membrane sandwich. And last, membrane layers wrapped around permeate tube and cracked spiral shape. How it works? Feed will travel through the flow channels tangentially across the length of the element. Second, filtrate smaller than molecular weight cut-off will then pass across the membrane surface into the permeate space. Then carry down the permeate spacer towards the permeate tube. And last, the remainder of the feed then becomes concentrated at the end of the element body. The video will be provided at below. For screw pump, it also known as a water screw, is a positive displacement or PD pump that use one or several screws to move fluid, solids, or liquids along the screw. How it works? Two counter-rotating screw rotors are used in screw pumps, and they are designed to rotate towards each other. The gas is trapped between the rotor screws. This compressed volume reduced as the screws spin, compressing the gas and moving it into the exhaust.
Among the advantages we get if using enzyme membrane reactor is the opportunity to develop a continuous process. Next, the possibility of better control. In addition, the arrangement and concentration of the product in the process flows. Thereafter, an increase in the rate of the product inhibits the reaction. Further, less enzyme is used is also one of the advantages when we use enzyme membrane reactor. Next, the perfect research tool of enzyme mechanism. The next advantages of using an enzyme membrane reactor is that better enzymes may be used without economic runaway. The next advantage is less waste may be produced, and the last advantages we get are maturation and clarification are integrated in one single stage. Apart from that, there are also the advantages that I can identify if we use enzyme membrane reactors. Among the advantages that can be identified are that the absorption and poisoning of the enzyme are unpleasant. In addition, the inhibition of the product substrate on the membrane surface. Next, the enzyme leak. Further, enzyme inactivity with shear-related effect. And finally, the loss of enzyme or factor activation is also one of the advantages we get if we use enzyme membrane reactors.
So, that's all from us. Thank you. Hope you enjoy watching this video.